Can you hear me? Hello, can you hear me? Okay ra, kutingog, laro ra. Guys, okay ra, laro ra tingog.
Yes, sir. Clara, sir.
Okay, so good morning, everyone. May buntag. So this meeting, our discussions would be focused on chapter number 2. So this is about analysis of two-dimensional trusses. Okay, so the previous meeting we discussed about the analysis of one-dimensional bars, which is the simplest form of uh, structural system. Okay. So I guess all of us are quite familiar with trusses, and even including the assumptions, no, for an ideal truss. So anyway, let's start with its introduction. No? So if you will recall from your basic structures coursework, that several assumptions were made when we consider trusses. No? So highlighter. Uh, Sama yung highlighter. Okay, kanina na. Okay, so going back to our discussion, so when we say an ideal trust, so we have these few assumptions. No? So first, the members of the trust were connected only at their ends. Okay, second, the connections between the members of a joint consisted of frictionless pins. Okay, so ang joints niya hinges or frictionless pins. So that means dili siya mo rotate. So wala siya ay moment. Third assumption, the members of a trust must be straight. And last one, the loads must be applied at the joints. So basically, these are the basic assumptions, no, of an ideal trust. Okay, as a consequence of these assumptions, we found that each member was a two-force member. So, of course, with those assumptions, it is safe to conclude that each member is a two-force member, no? So, having only axial force. So that means it's either tensile force or a compressive force. So a truss member, ideally, is a two-force member. So axial force lang siya, no? It's either tension or compression. So of course, assumptions 2 and 4 above are generally not valid in real structures such as timber of truss, but they do provide us with primary solution to the problem. Actually, in actual situation, it's really difficult, no, to uh, consider an ideal truss. Okay? So, kay building man na dito ang mga joints ra po niya, continuous ra po. So that means dili siya mo behave as frictionless pin or hinges ang iyang mga joints. So, naagid siya yung mga moment na develop. However, kana siyang assumption gyapon nato nga ideal trust gyapon na siya. So it can more or less simplify the analysis. Okay, so it can more or less provide us the primary solution of the problem, which is the analysis of the trust. Okay. Pero in reality, naagin na siya yung mga moments ang iyang mga members. So, secondary solution accounts for the end fixity and loads applied at intermediate joints, no? So then we have to superimpose that, okay, before we design the members. Okay. So when we considered one-dimensional bar element in chapter 1, the elemental axis was oriented along the length of the bar. Okay, sa one-dimensional bar, ang iya sa iyo na kay siya kay we consider only one axis. And it is the axis along the length of the bar. Okay? So ang difference ni karon ug mingon kag trust na siya. So for example, mo ni karon ang akong axis ana unya diri morning x. For example, mo ni akong y, nya mao man ako, let's say mo ni akong trust member. Okay? So meaning na kay displacements along the x and the y axis, di ba? Okay. So that's the main difference between a 2D truss and the one-dimensional bar. So the global or system X for the entire structure, okay, we consider the whole system. So naturally, there was a single displacement at each node, also oriented along the bar axis. In other words, the elemental X and the global axis were in the same direction. That is, kung pareho silang direction, so more or siya mo behave as a assuming also nga ang load niya along the direction of the length of the element, no? Which is very seldom in a truss element or a truss system. So a two-dimensional truss element, however, can be oriented in any direction in the x and y plane. Right? So as a result of this, the elemental axis, okay, which is the axis along the element of your truss member, okay, so which is again considered to act along the length of the truss element, no? From left to right in general will not be parallel to the global or structural system coordinate axis, no? So going back to the figure that I presented earlier, assuming mo ning akong truss element, okay, so naa kay iyang elemental axis, di ba? So along the bar element, so kani mo ni karon ang akong elemental axis, no? Okay, so x and this is maybe y. Let's just put here prime, no? Because it is not the oriented along the global x and y, no? So ang global x and y mo gini siya, no? Okay? Mo ni akong global x and y. So in other words, natay duha ka axis. Kani siya gitawag ni elemental coordinate axis, while this one mo ning akong global coordinate axis. So one of the challenges, no, for the analysis of a truss element is we must be consistent. Okay? So from the elemental, ato sa ginasa convert to global, no? So before we proceed with the analysis. Okay? In addition, since an unrestrained joint in the structure can displace in its plane of the structure, we must allow for two displacements at its node. Okay, so going back again to the figure, morning akong truss element, for example. So there are two nodes per element. Okay, so basically, ang sa one-dimensional bar na to, ang iyang movement is only along the direction of the axis, no? But here, na naman kay displacement, no? Along the X, you also have a displacement along Y. So in other words, na kay duha ka possible displacements sa imong perno. That also means nga duha ka buok ang imong degree of 2 degrees of freedom per node for a truss element. Okay? Now, in each element, there are 2 nodes. So that means the total number of degrees of freedom per truss element is 4. Upat na siya ka buok, no? So we have to expect ang akong K 4 by 4 na siya, no? Okay? So, ang size niya should be 4 by 4. Okay, E11, no? E12. So, morning akong K, it's a 4 by 4 na siya. No? Per element na siya, ha? Okay? Sa one-dimensional bar, kadali na to kay kuha naman to. 2 by 2 naman siya per element. Okay? So, since it is always simpler to derive the elemental stiffnesses with respect to the elemental coordinate system, we must find a way to transform all of this, okay, the forces, the stiffness, and the displacements in terms of the global coordinate system. Okay? So that's the challenge, no? So from the elemental coordinate system, we have to transform this into global coordinate system. Again, as what I emphasized earlier, we must be consistent, okay? So once we transform that into the global coordinate system, we have to combine that, no, to form the structural stiffness matrix. Then after that, we reduce. Then we have to solve the displacements. After that, we have to solve the forces. And finally, the member forces. Okay, so that's how to complete the analysis of the structural system. Okay, so again, we have to express all these quantities in terms of one coordinate system, and this is the global coordinate system. Okay. So we discussed about this coordinate transformations. No, we mentioned that we need to transform this into one single coordinate system, and again, that is the global coordinate system. So if we go back to this figure, mo ni ang akong truss element. Ini. Maybe. Assuming morning akong one in green, morning akong truss element. So morning iyang node, no? Node 1, this is node 2. So this is node 1, this is your node 2. Okay? So karon mo ni ang akong elemental coordinate access, no? So kani mo ning akong x prime. Okay? So denote the elemental coordinate access. This is my y prime. Okay? Now this one is my global coordinate access. Okay, so in terms of the global coordinate system. Okay, so based on elemental coordinate system, so kaning akong truss member, so move ba na siya, no? So on the x and y directions with respect to the elemental coordinate system. So kani siya, kita ta color. So kani mo ni, no? Akong movement. So let's denote that as delta 1. This is your delta 2. Okay. So let's denote the Greek lowercase delta for the elemental based on the elemental coordinate system, no? And for global, let's just denote that as U. No? So let's just be consistent with this book. No? So here, this is delta 1, delta 2, this is delta 3, and this one is your delta 4. So meaning kaning delta 4, mao ni karon ang akong joint movement along the y coordinate in terms of the elemental y coordinate axis. Ang delta 3 in terms of the x elemental coordinate axis. Okay? Now, in terms of the global, so na akong gani, no? Morning akong U1, mo po ni akong U2. In terms of the global na sa U3, for example, this is now the displacement, the joint movement along the x global coordinate axis. Okay? Na kaning U4, mo po ni ang along the y global coordinate axis. Okay? So again, duha ni kabuok, no? So naatay sa elemental. Okay? We also have the global na to, no? Okay? Sa elemental na ko, mo ning kaning mga x prime, y prime, di ba? Sa global na ko, mo ning akong x on y, no? So again, using the Greek lowercase delta and u for the global. So again, as emphasized earlier, ang challenge nato karon is we have to transform, okay, all these elemental coordinate nga mga variables, no? So in terms of global. So before we start our analysis, okay? So it actually boils down to this diagram. So kanira gid na siya, no? Okay, kay makakita ka na og mga relationship, di ba? Assuming ang angle from the x global coordinate axis to the elemental x-axis is theta. Okay? Assuming theta siya, no? So kani importante kani ang angle. Ang theta na to is the angle from the global x to the elemental x. It is positive if it is going counterclockwise in direction. So well, that is based on this diagram, no? Okay. So from here, we have to express, no, or relate these elemental variables to global variables. So in terms of this delta in terms of u, we can express this in terms of theta. Okay. So kanina lang ta, no, para di na ta mag-usab-usab drawing. Okay. Okay. Yeah. Right. So assuming mo ni ang akong node, okay? Then pag-apply na ko sa load, so ni-move siya dinhi. Okay? Mo ni ang akong x elemental coordinate axis, while this one is my y, no? Kani. Morning x. Morning karon ang akong y. In terms of the elemental coordinate axis. Okay? While this one is my global axis, no? X. Morning karon ang akong global y. Okay? So karon mo ni ang akong mga movements sa akong nodes, no? So kani from here, i-move siya dinhi. Okay, so meaning na ako'y mga in terms of the elemental coordinate axis, so na ako no? Mo ni karon ang akong katawan. Okay, mo ni karon ang akong delta 2. Okay, delta 1 and this is my delta 2. Okay. Now, kani mo ni ang akong angle. Kani by the way, mo ni ang akong U1. Okay? Mo po ni karon ang akong U2. No? In terms mo na siya sa global. Okay? In terms of the local, mo po ni siya, no? Kaning delta. Now, remember, ang assumption na to sa atong theta is the angle from the global to the elemental x-axis. So, mo ni karon ang theta. So, from this diagram, we can somehow formulate or relate, okay, the global to from the elemental going to global. Okay. So if this is my theta, okay. So karon mo ni akong U1, so kani siya mo draw kog 90 degrees diri. Kani siya is U1 is my hypotenuse, no? So kani siya is my, this is simply U1 cosine of theta. So mo ni siya, no? Okay. U1 cosine of theta. Alright. Now, kani siya, this is U1 sine of theta. U1 sine of theta. Okay. Now, let's go to sa U2 po na to, no? So, kani siya nga portion, no? This is my U2, di ba? Kani siya 90 degrees. So, meaning this is the hypotenuse. Okay, so if this is theta, then this is also theta, no? Okay, so meaning kani, this is U2 cosine of theta, while this one is, mo po ni siya, no? U2 sine of theta. So from this diagram, so your delta 1 is simply equal to U1 cosine theta plus U2 sine theta. So in other words, we were able to express this delta, which is the, in terms of the local coordinate axis, no? In terms of your U1 and U2, which are in terms of the global coordinate system or axis. So at the same time, kaning akong delta 2, mao maning akong delta 2 from here to here. So it's simply equal to U2, kani U2 cosine theta, then minus U1 sine of theta. Okay, so we have now this relationship. Okay, so yeah, this one, mo man siya, no? U1 cosine theta plus U2 sine theta. U2 cosine theta minus U1 sine theta. Basically, gikan na din nga diagram na to. Okay, now remember, when you say matrix, kuan mo na siya, kaning, that's basically somehow sort of series of linear equations. No? We can transform that in matrix one. So on this, okay, relationships considering one node. So if you want the U3 and U4, then you just change this to U3 and this one is U4. Okay, this is delta 4, so this should be U4 minus U3. So from there, mamaman no? Okay. So from there, ma-relate na ni nako. Okay, so we have now a series of linear equations. So we can relate now this into this one in matrix form. Diba? So may kag delta 1, so it's simply equal to kani times kani, diba? So mo nang U1 cosine theta plus U2 sine theta, and the rest are zeros. Okay, delta 2, for example, so second row, first column. So U1 minus sine theta, no? And so on. U1 minus sine theta, then plus U2 cosine theta. Okay. So from here, makuha na nako nga kani mo ni ang akong some sort of transformation matrix. This is how I transform from local to global. What I need is simply the angle theta, which is the angle, please take note, this is the angle from the global x-axis going to the local x-axis. Okay, the direction positive if it's counterclockwise direction. It should be counterclockwise direction because that is based from assumption. Otherwise, kung ay sa naging mga assumption nito, then there will be changes on the transformation matrix. Okay? So kani mo rin matawag na ni nato og transformation matrix, no? So or here itawag ni siya og beta matrix. Beta or simply transformation matrix. Okay? So it's pretty simple. So now the length of the displacement vector must be the same in both the system and the elemental global coordinate system. So kani siya mo man ang length sa akong vector, meaning ang akong total displacement sa akong node. Okay? So of course kani siya equal ra gyud ni siya sa resultant ani na. So it could be kani siya kani o kani nga triangle, di ba? Pwede po sa in terms of global kani o kani nga triangle. Di ba? So mao ni nga akong total displacement. Okay? So this is equal to the hypotenuse naman na siya, no? Delta 1 squared plus delta 2 squared equal na po na siya to U1 squared plus U2 squared. Okay? Mao ni siya. Okay, and this can be written as this one. Since your delta is equal to beta times u, which is the transformation matrix, then you will have this relationship also. Simply, mo na nang ibalik, no? So you get the inverse, right? So if we simplify this, then we can come up with this relationship, kani. So what does it mean? The transpose of your beta matrix is simply equal to its inverse. Now, if we have this relationship, okay, it means that we have now an orthogonal coordinate system. So because this is the property of an orthogonal coordinate system, we have this in more differential equations. Okay, so let's proceed. Now remember, we have this relationship, no? So ang atong delta matrix, di ba? Equals siya to the beta matrix. Itong beta matrix of the transformation matrix, multiply this by the U matrix, no? Morning akong displacements in terms of the global coordinate system. No? It is also safe to say nga in terms of the force nako, or sad gihapon, no? Okay? So kani siya nga P, mo ni karon ang akong force in terms of the elemental coordinate axis, kani mo ni akong force in terms of the global coordinate axis. No? Okay? So that's how to transform from local, okay, to global. Okay? So, since kani, equal man na, di ba? K times delta. So, take note if this is P, this should be delta. Meaning, this is in terms of the elemental or local coordinate system. Okay? Alright? So, kani siya, equal siya to K delta niya kani, maura man no? So, B beta then times x times u. Okay? What happens next is So i-substitute mi nako. Butang nako diri, di ba? Kani diri. Naki beta u, right? So k beta kani siya times since the force displacement relationship for the global fluid system can be written as this one. So in terms of the global fluid system, so kani siya is ang F. Ang atong K, take note, dako ni siya nga K because this is in terms of the global coordinate system, no? Na since kani pong F in terms of the global, in terms of the local, P to siya, take note ha. Una kaning K, niya delta. Okay? Sa global kani pod F, dako nga K, niya U. So kindly take note of this kana nga mga ipang-denote nato, no? Okay? So, ipang-substitute minimo diri karon. So, and by virtue of this equation 2.7, which is kani is equal to kani, diba? The transpose is equal to the inverse because of its orthogonality property. Then I can come up with kaning relationship na to, no? Okay. So, this is how to get your K in terms of the global, no? So, mo ning akong K in terms of the global na siya. Okay. So, this is the elemental stiffness matrix, then the beta matrix, which we have discussed earlier, which is in terms of theta. Okay? So, in terms of the angle. Okay? Kaya may importante, di ba? Kaya once we have this K, di ba? Ana naman na, F, di ba? Yeah, K. Okay, then U, di ba? So, nakuha ng K. So, per element, ako siyang i-combine, okay, to get the K of the entire structural system, okay, then reduce, maura gina siya, no? Solve na sa nako na ang mga displacement, and after that kani, then after that ito na sang P. These are the member forces. Okay, so mao na ni ang result karon, no? So actually mao na ni ang inyong tigamnan yun kani. Diba? Kaya ang katong imong mao na ni karon ang akong K global na siya, no? So in terms of per element na siya, ha? Okay? This is per element or per member, no? So mo na gitawag elemental stiffness matrix, no, in terms of the global coordinate system, no? Okay? Or mo ni ang elemental stiffness matrix in terms of the global coordinate system. O kani? Elemental stiffness matrix in terms of the global coordinate system. Mo ni siya, no? So kaning C stands for cosine of theta. So in other words, solve na nimo ang naman kay value sa theta, which is very important, no? Solve na nimo cosine, you square, put butang nimo diri. Again, we expect that it's a 4x4 matrix. Why? Because per element, there are 4 degrees of freedom. Okay? Ang sa one-dimensional bar, 2x2 lang to siya because per element, there are 2 degrees of freedom. There are 2 nodes, no? Na per node, you have only 1 degree of freedom for a bar element. But for a truss, we have now 2 degrees of freedom per node, per joint. Okay? So kini yun sa nako pagkuha kani sa taas kani, no? Ora ni siya, no? So na naman tay beta, we have also the K, di ba? So akong bulikon diri sa taas, mo na ni ang akong beta. This is the beta. Okay? Kani beta matrix. Ang K per element is also centered earlier, which is very, very simple, no? For kani, mo ni siya, no? Nor coordinate for the bar element po. Okay? So, ipang substitute na nimo tanan, mo na to makuha na nimo ang kanisingin niyo ra yung tigamnan. after all the discussions we have made, kanila. Ora gina, importante is ang kanang K per element, no? Okay. Now let's discuss an example problem. This one. So we have this trust. Okay. So how many members in this trust? There are 3 members. Okay. So kani morning ako 1, 2, 3, 4. So meaning man ako member 1. Morning ako member 2. Okay. Morning ako member 3. There are how many nodes? 3 nodes. Okay, there are 3 nodes. How many how many degrees of freedom per node for class? There are 2 degrees of freedom, right? Now there are 3 nodes. So that means we expect that the K of the system, not the elemental, no? Okay, K global sa system, no? System. Okay, the size should be what? 6 by 6. Total degrees of freedom is 6 man. I have to expect, no? 6 by 6. 6 by 6 ang iyang one kanang system stiffness matrix. Okay? Kung element ka, of course 4 by 4 again na siya, di ba? Katong atong i-present kaniya, no? So per element. Now, I'm using here, take note, I'm using here big K, meaning in terms of the global. Okay? Global na tanan. Okay? So let's proceed. So, no? Per element ni siya. Kani sa element 1, pa-take note, kaning atong mga angle. So for example, kani, element 1. I think I have to present here kung ano lang, kanang katong program sa Excel, no? Anyway, kaning matrix is just programming na gina. I have to stop sharing this. Guys, katita ra mo? Screen? Can you see the screen? Kaning duha?
Yes, sir.
Sige, so this is a sample program in Excel, no? So this one is for analysis of two-dimensional trusses. Okay? So ang buhaton na ninyo is first you have to set up this elemental stiffness matrix with respect to the global coordinate axis. So unsa ganitong global kani mo man no? Kani. Ora gini. Okay, so makita ninyo karon kani siya is cosine squared ni siya, no? Okay? Cosine times sine, no? Okay? So, in this example, so E is, yung E, ano niya? So, ating ba siya E? Okay. So, going back to our example, no? So, assuming E is, for steel, normally it's 29,000, no? PSI. Or 29,000 PSI, no? Or 29 million PSI, no? So, assuming the area is 1, no? So, the length, by the way, here is, in this case, 120 inches, no? So, is this, for example, 2 or wait, no, I think this is for 5 members. 0.1, this is for the kuha ni siya. Kanang sa problem siguro ni, no? Let me see first, no? So, malibog to din eh. Find the overall stiffness matrix. Okay, yeah. Yeah, kaning 2.1, this one is for the kuan din eh, for the problem ni siya, no? Sa assignment. By the way, for this problem, so dili ta maka kuan ani sa program. Why? Because we don't have the value of E. Pwede na, you can make this as 1. The area also is 1. The length L here. So you can also consider that as 1. So kanisya should be, well, square root of 2 or 1.414 na siya. No? Okay? So I just would like to show you the program here. So basically, mo ni karon ang atong key global, no? So it's 4 by 4. I have these markers, no? Kani siya is simply cosine squared, no? So, well, in terms of theta, gini siya, no? But here, ako na siyang i-modify gamay para ang akong, instead of mo-solve ko sa angle, so akong ipangbutang na lang dari ang iyang mga coordinates. So, ang program na mo i-solve sa angle, no? Okay, so, for example, kani siya, so pwede ko maingon nga, assuming, no? Kani mo ni ang akong, well, this one is the global, di ba? X, this is the Y. Now, for this element, kung mo ni karon ang akong element 1, okay, mo ni akong element 1, ang iyang local, pareho ra sa global, di ba? So what is my theta in this case? Theta is simply equal to 0. Is it correct? Okay, that is for element 1. Okay? That's very important, no? Ang kaning element 2 nako karon, remember ang theta is from the x global to the local. So for example, if this is my element 2, nya mao ni nga akong orientation sa akong element 2, mao ni karon ang akong x prime, no? Okay, namo ni akong y prime karon. So mao ni nga akong value sa akong theta. Okay? Which is 90 plus okay na, importante kay siya, no? Ang theta 3 nako, okay, so pwede ko from here going here. So very importante sa kayo ang imong pagkuan sa imong orientation, no? So if this is my x prime, so kani ang akong theta 3 is 90 degrees. Mao po rin akong y prime. That is for element 3. This is my element 3, no? Okay? So in the program, makita ninyo nga it's na kaning mga nodal coordinates siya. Okay, so if you have input the nodal coordinates, of course, you can compute also the angle. Okay, and from the angle, so you can compute the mga cosine and sines ninyo. No? So basically, mo ni ang result karon. Okay, so makita ninyo nga so sa program kani siya is only for 2 members. This is really not for this one, for this problem. Okay, it's only for 2 members. So karon mo ni ang akong for element number 2. Okay, mo ni ang akong elemental. Mora gyapon to, solbo ni akong key global based ra pud ani niya, no, kani. Okay, so solve ni nako siya. After that, I have to combine. Combine ako, mo na nagtawag na ako og system stiffness matrix. Okay, or the stiffness matrix of the entire structure, the system. Okay, so pag combine ako, kadto gyapon gamit ko sa mga markers, no? So like what we did for the for the one-dimensional bar. Okay? So mao na ni karon ang akong force displacement relationship, okay, for the entire structure. So after that, I have to reduce by simply applying the boundary conditions, those with zero displacement. So I have to remove the rows and columns that corresponds to zero displacements. From here, masolve na nato ang akong displacement. So simple as that, no? O na ni ang akong displacements. Okay? Once I have the displacements, masolve na po nako ang akong member forces. Okay? So katong elemental, beta, so masolve na nako na siya. No? Ang akong P. So, balik ta diri sa example. So kani mo ning akong mo ni ang programa. So mo ning inyong buhaton sa inyong mga assignments na starting from the two-dimensional trusses. The minimum requirement is you use Excel. No? Ang problema sa Excel lang medyo semi-mano-mano lang siya. No? Okay, so kani siya is for 2 members lang, di ba? No? So, mura kag magtrabaho gyapon. The only difference is di na ka mag i-program na lang nimo ning mga key global. Pero ang pag-join nimo mano-mano gyapon. Okay, pag set up nimo sa imong overall stiffness matrix. But kani program na ni siya buhaton. Kani mga yellow mo na ning imong pang-input. Okay? Kani siya is for assignment 2.1. Akong tanaw na to, ganin lang tang example na to, kaning 2.1 na lang. So at least sa inyong assignment, ano na mo idea daan na no? This is 2.1, no? Okay? So sa 2.1, okay. Mao ni karon ang akong trust member kani. So pila ka members siya? Duha ra ka members. Na pila man siya ka nodes? 1, 2, 3. Tulo ka nodes. So, per node, duha man siya ka degrees ang freedom. So, that means, ang akong K system, the overall stiffness matrix na ko should be 6 by 6. 3 nodes man siya, di ba? Okay? So, gihatag na ni ang E, ang area sa 1, member 1, ang area sa member 2. Now, let's start with member 1. Mo ni ang akong E, 29. Gihatag. Ang area na Okay, so and in this case, ang akong access is kani, mo ni akong gihimo nga kuan karon, no? So X and this is Y. So mo ni akong node 1, 0, 0 siya. Ang node 2 nako is we have to be consistent with the units also. This is in inches. So ang akong kuan should also be in inches. So node 2 nako is 120 because this is 10 feet times force 12 inches per feet, no? Yeah, 0 ra gyapon siya, no? So ma-solve na nako ang akong mga angle, no? Okay? So after that, ma-solve na ni nako ang key. I have to put the markers, no? So 1, 2, 3, 4 because this is node 1. So ana man na siya, no? Kani siya 1, 2, kani siya is 3, 4. Kani siya is 5, 6, no? Okay, that's also important. So next is node 2 na pud ko kani. Okay, mo lang gyapon. I have to input the E. The area now is 2. Okay? So ang akong sa member 2 nako karon is kani, mo man akong this one, no? So mo man akong node 2, node 3. So mo ning akong member going here, no? Okay? So ang akong node 2 mo ni siya 120, 0. Ang node 3 nako karon is 0 siya, ang X na, di ba? Mo man akong reference axis, di ba? So you have to be consistent. That's very important, no? So X and Y. So ang akong Y karon is negative 60 negative because it is going downward, no? So ma-solve na to. Ang angle nako, see if I really want to get the angle, remember ang angle nako is from the global x-axis going to the elemental x-axis. In this case, kani man ang akong gibuhat, no? Mao man ni karon ang akong x prime, di ba? So meaning ang angle nako should be this one. Mao nang akong theta, no? Okay. By the way, in this program, I made some changes, no? But the idea is basically the same ra gyapon na, no? So, mao ni akong gibuhat, no? So, ma-solve nako na ang this case, ang angle nako should be ma-solve man no? Kani siya ang angle arctangent 5/10, di ba? Okay. So, plus 90 degrees. Okay. So, after that, kani siya, remember, this is cosine squared ni siya, di ba? C squared mo na siya, no? Kani cosine and sine. Uy. Ano naman eh. Can you get your calculators? Ano naman?
116.57, sir.
1,
116.57.
5, 7 degrees, no? Okay. Now, remember, dapat ay EA over L, no? Times cosine squared na siya, di ba? Tanawan sa itong,
Jesse Meredith Smith.
no, tawag na po ni mo totoo na. Tawag ko, kaya na po yung klase. Ha? Itong, balik na dere sa, ano eh, napaka EA over L times cosine squared, no? So remember this, ha? Kani, na cosine squared, cosine sine, para ma-check lang nato, ha? O pila tong atong angle na wag tang ninodra, sorry. Kani man tong atong angle, no? So that's for member 2, ha? 116, how much?
116.57 degrees, sir.
57 degrees. Okay. Now, pila man ang akong EA over L. Remember, ang akong, kani man eh, ang akong area. Ang length nako dere, pila man ang length dere karon? L2. This is 5 squared plus 10 squared. Di ba? Square root of 125, no? Okay, square root of 125 na siya, no? So, ang kani siya, equal man ni siya to E over L times cosine squared, no? So, ang E nako is 29 times 10 to the 6. Ang area nako is 2. Ang length nako square root of 125. Di ba? Times the square of cosine of 116.57. Okay? Squared. Please check kung mao ba ni ang result. Please check. Please check. Uy, sorry, feet pa man dahil ni. So times pa dahil ka. So natay sayop, no? Kani siya is in inch pa ni siya. Feet. So times 12. Di ba? Times 12 pa na siya. No? Oo ni, no? 134. Can you check? Please. think we also have kani siya is dili ni siya 116 no, but kani 180 na gunadaan, di ba? I think this is 206.57 no. So this is 206.57. No? Mm, 345, 845, 12, no? Okay, so this one, mauna ni siya, no? Nakuha na ninyo, so ako din siyang gituyo, no? So parang careful with kayo mo aning angle. Grabe na siya ka importante. So from the X coordinate axis going to, in terms of global, no? Going to your X elemental coordinate axis. Guys, nakuha na ninyo?
Yes, sir. Yes, sir.
Okay, that's good, no? So maura gini, program na ninyo tanan, no? So kadto makuha na ninyo, after that inyo na siyang combine. Mao na ni pag-combine ninyo, no? Now take note of this kuan ha, kani nga mga markers 3, 4, 5, 6, no? Okay. So ang problema ninyo ani karon is inyo lang ning tagsa-tagsaon, di ba? No? So 1, 1 for example, mao ni 2, 1, mao ni, no? 3, 1. Do we have 3, 1 here? Wala sad, no? So mao ra sad ni, no? Okay. 4, 1, so on and so forth. So kani siya, for example, ma-add na siya, no? Kay kani is 3, 3 man siya. Naman ko 3, 3 din kani and this one. So mo na nag-add na ni nako, no? Kana og kani. So mo na problema sa Excel kay medyo inyo pang kuan mano-mano, no? Pagkuha sa overall stiffness matrix kani. After that, i-reduce nimo, solbo nimo ang imong displacement. So simple as that, no? After the displacement, ibalik nimo dinhi, masolve na po nimo ang forces sa imong mga reactions. No? After that, balik ka diri sa imong member forces. Kani in terms of the elemental, kani elemental po ni siya, no? Elemental stiffness matrix na to, no? EA over L, nakadto mo ning 1, okay? So sayo na ni, no? EA over L naman na siya, no? 1, no? 1, 0, negative 1, no? After that, you solve this member forces. So quite, maura gid ang inyong buhaton ninyo, no? Mag-anam na siya og dako na lang. So kani sa assignment 2.3, 5 members ni siya. So mo ni 5 members. Kana after that, i-combine nimo, reduce, solve the displacement. Ana ra gid siya, no? Okay. Kani sa inyong example, 3 members lang. By the way, take note, kani siya ni gawas ni sa board exam last May 2009. Duha ka members gyapon niya ipa-analyze gyapon sulbo ng imong mga displacements. At that time, the problem was wala pa ni sa gitudlo sa kuan sa undergrad, no? Sa masteral na ni siya. You have any questions, clarifications? Excel, ini pass, yes, no problem. So, karon mag-start na ta sa Excel, no? So, ang inyong assignments, ako lang i-kuhan, i-post sa Canvas, no? So, for the assignment of your two-dimensional trusses. No? By the way, we will no longer include na lang, no? Kaya mga temperature changes, no? as well as kaning mga support movements. So para di na ta malibog, no? So ang atong discussion, so up to kanina lang no? Itong basic na lang, kanina lang, no? Okay, so we will no longer include kaning mga support movements and temperature changes. So next meeting, ato na punta sa two-dimensional beams and two-dimensional frames. Mao lang gyapon, buhat lang gyapon ba ni o program, combine, no? Reduce, solve the displacements, and solve the member forces and the reactions. Yeah. Any other questions, guys? Sir, when mag-exam? Oh, ganahan din mag-exam. So, sige, magbuhat ta og ano, exam. So, ano na, ganang assignment, no? Then I think during the finals, nalan siguro tay oral na lang siguro, no? So, mga tana ko sa mga yung programs, no? To ensure nga nagbuhat siya mo, no? Alright. That's all, guys. Thank you for your attention. So, thank you for joining in this one, no? Meeting. So, see you next week for our chapter 3. So, chapter 3 the next week. Thank you. Yes. Hmm. Hmm. Okay na siguro na, no? So, may buhaton na to na. Usbo na to sa canvas. Hmm. Sige, walay problema, no? So, I have to change sa canvas ang iyang deadline. Thank you.